In this video, we are going to take the limit of this function. So this is a rational function, and then we're taking the limit as x goes to -2. So what we do is just plug in that -2 and then see what we get, and then go from there. All right. So plugging in this -2 for x, I get 4 times -2 squared plus 13 times -2 plus 10 all over -2 to the 4th plus 11 times -2 cubed plus 18 times -2 squared. All right, and so now we need to work out all of that. All right, so -2 squared would be a +4. 4 times 4 is 16. So on top I'd have 16, and then minus 26 plus 10. On the bottom, -2 to the 4th power would come out to be a +16. All right, and then -2 cubed would be a -8 times 11. That would be -88. And then -2 squared would be a +4. 4 times 18 is 72. Okay. All right, and so on top I have 16 plus 10 is 26. Minus 26 would give me a 0 on top. And on the bottom, 16 plus 72, that's 88. Minus 88 is going to give me a 0. So we have a 0 over 0. Remember, that is an indeterminate form. Okay, and that is never the correct answer in one of these limit problems. Okay. And so what we have to do, just like in the previous video we talked about, when you have a rational function like this, what you want to do is to factor both of these. And then something will cancel out, and then we will try to factor this again. So you can factor those polynomials however you want to. There's many different techniques for doing that. One of the things that can make this a little bit easier is something from algebra that it's called the Factor Theorem, right? The Factor Theorem says that if you have a polynomial, and that's what a rational function is, it's a polynomial divided by another polynomial. If you plug in a number into a polynomial and you get 0, like we did on the top and the bottom, right? Then, so if you plug in some number c and you get 0, right, like we did, into a polynomial, then that means that x minus c is a factor of p of x. Okay. So in this case, right, when we plugged in that -2 into the top, we got 0, and also in the bottom we got 0. So what that means in this case, right, in this particular problem, that x minus a -2, right, which we we usually write as x plus 2, right, is a factor. So what that means is that on the top, you can factor out an x plus 2. So that actually is going to help you factor this more easily than you normally would be able to. So for instance, on that top polynomial, factoring this is usually a little bit more difficult, right? Because of the fact that that this number is a 4 right here. So that usually takes a little bit longer, but we know that one of the factors has to be x plus 2 on the top, right? So it has to be x plus 2 times some other binomial. And now that you know that this one is x plus 2, well, that means that this first term over here has to be 4x, right? There's no other way that that can happen, because the first times the first is going to have to give you that 4x squared, right? Likewise over here with this, since the last term is 10 and we know that this one is a plus 2, well then the other term is going to have to be a plus 5, right? Because that last times last, this 2 times the 5, is going to have to come out to be a positive 10, okay? So we know it has to factor like this, all right? So that's how the top one factors. And so it's this factor theorem is really, really useful in these problems. It kind of tells you half of the factors that you have in here. And then it's really easy to get the other one because you just look at the first and last terms and figure out what they would have to be. Okay? All right, so that's the top one factored completely. On the bottom one, notice it's x to the 4th. And we probably should have checked that up here, but this 13 is really going to mess things up. Remember, the first step in any factoring is to factor out the greatest common factor. Up here, the greatest common factor was 1, right? But down here, we can see that all terms have at least 2 x's in them. So that's what we want to do first, right? So you should always factor out the greatest common factor first, which for these 3 terms here, here, and here is going to be x squared. Okay. Okay, so when I factor out the x squared out of this x to the 4th, I get this x squared. Then out of here, I get 11x. Out of here, I get 18. Okay. All right, and so now then I would continue to factor, just like I was doing before. And again, I am going to use the factor theorem. All right, so this bottom function here is a polynomial as well, right? And so therefore the factor theorem also applies. We plugged in a -2 and we got a 0, right, back here. So that says that x minus a -2, which we normally write as x plus 2, right, is a factor of the bottom polynomial also. So we know, right, that it has to be x plus 2 times something else, right? And then all we have to do is figure this out, but we can see, right, if the first term over here, x times something gives you x squared, well, it has to be x. There's no other way around that. And then the last times last is going to give us this 18. We have a 2 here, so that means that this has to be a 9, right, because 9 times positive 9 times positive 2 is going to give us that positive 18, okay? All right, and so now we have the top and bottom completely factored. What we can see is that there is a common factor there of x plus 2, right? Once you factor everything, then, right, you can cancel the common factors between the top and the bottom. So this x plus 2 and this x plus 2 cancel each other out. All right, and so what you wind up with is rewriting that. I have the limit as x goes to -2 of 4x minus 5 on top and x squared times x plus 9 on the bottom. Okay. So now that something is canceled out here, we are going to plug in the -2 again and then see what we get. All right, so when we plug in the -2, we get 4 times -2 minus 5 over -2 squared times -2 plus 9. Oops, and I just noticed that I had a mistake here, which I need to fix. When I copied this over, I accidentally made it a minus instead of a plus. So I need to change that here and here. Right, when I wrote it over here, I accidentally made that a minus. So that should be a plus, right? This should be a plus right here. Okay. All right. That looks better. And so we get -8 plus 5 on top. On the bottom, oops, let me finish that here. On the bottom, I get negative 2 squared. That is a positive 4 times 7. All right, and then keep simplifying that. On the top, I get negative 3. On the bottom, I get 28. Okay. This does need to be reduced, but 3 doesn't go into 28 evenly, right? And so that's the final answer on this problem here.